In this video, we'll go over how to configure your IN100's GPIO pins in the input and the output modes, and go over the different settings for each of the GPIOs as well. So let's get started. The power of using the IN100 is in its flexibility and the ease of use of its companion tool, the NanoBeacon Config tool. It allows you to build complex applications in a very quick and easy way. For example, you can configure up to 3 advertising sets, each with a different advertising name, with a different Bluetooth address, with different advertising data and parameters, and even triggers. It's almost like having 3 different tags in one small device. And as with any embedded device, the IN100 also features a number of GPIOs. It offers 6 GPIOs that can be configured with a number of different options. In this video, we'll go over these different options and how to utilize GPIOs in your IN100 based application. Let's take a look at the GPIO section within the NanoBeacon Config tool. The different options for each GPIO are digital I/O, settings, the pull up, pull down, the advertising trigger, the wake up, and the latch. Under digital I/O, you have multiple options. You can disable the GPIO, you can set it in as an input or output with low or high voltage. You can leave it at default, which is set up to be input by default. And then you can also do a wake up high and sleep low, so it changes its state based on the state of the device. Now, a couple of things to keep in mind when configuring GPIOs. If you are using the ADC functionality on a pin, for example, then you must disable the corresponding GPIO to turn off the digital I/O functionality. Second is that if you are using a GPIO pin as the input source for the one-wire sensor functionality, then the input or default option must be selected for the corresponding GPIO. The default option sets it to input. So if we enable a GPIO as input, we then have the pull up, pull down options, which include disable or pull up or pull down. Then we have the advertising trigger. In this case, we have a few options available. We have the disable, the high level, low level, rising edge, and falling edge. Once you have this set up, then you can enable the trigger for each independent advertising set. So say, for example, I set this up to be at a high level. If I go to the advertising and go to edit a specific advertising set and go to advertising mode, I can switch on the triggered advertising and then turn on the GPIO trigger source. So if we go set it to GPIO 2, now if I look at the GPIO settings, GPIO 2 is set to trigger when it reaches a high level or 1, and then it will actually trigger the advertising. So if we go back to the advertising, this is saying that if we have an advertising set that is set to trigger advertising mode, and we have a trigger based on the GPIO, the specific one, in this case GPIO 2, then we will be triggering based on the configuration for that GPIO. Going back to the GPIO settings, the next option that we have is the wake up, and this has 3 different settings: the disable, or high level, or low level. So what functionality does waking up the chip help achieve, and what are example use cases? Let's take a look at 2 examples. One is, for example, if you have an external microcontroller that's controlling the IN100, then most of the time the IN100 will be in sleep. But if the microcontroller wants to change the configuration during runtime, then the microcontroller must wake up the IN100. So if we have it enabled, then a high level, for example, will wake up the IN100. If we have it set to low level, then a low level on this GPIO pin will wake up the IN100, allowing the microcontroller, the external microcontroller, for example, to control and configure and change these settings. The other use case for the wake up is to use it for debugging purposes. So we can use the UART to read some states or some registers and check what's going on in case of a bug or an error state. The final option that we have is the latch setting. This setting is used to maintain the GPIO state when the device goes to sleep or wakes up. So by default, the device is in sleep, and the GPIO's default state is in the high Z or high impedance mode. And upon wake up, its default state is input with pull up. The different options within the latch settings are disable or latch in sleep, and unlatch upon wake up. For most of the application cases, however, the config tool will handle the latch automatically and users will not need to do anything special and change the setting. However, if a GPIO is configured as an output low or output high, and you want the GPIO to keep the state during sleep, then you should enable the latch for that GPIO. So now that we've gone through the different options and settings for the GPIOs, let's go ahead and configure the tag to utilize these options. And before I jump into that as well, if we can notice here that if we set a GPIO to output, then it disables the trigger and the wake up, because this is more relevant for the input use case. Okay, so here I'm going to set up an advertising set to transmit the GPIO status, as well as being triggered based on a GPIO trigger level. So first, let's go ahead and configure the GPIO. So this is how I have it configured. I'm going to be using GPIO 3 to output all the time. So it is latched. And as we described, latching means it will maintain its state in the sleep mode. Pull up, pull down is disabled, and the output is low. That's for GPIO 3. So this will be supplying the output. GPIO 4, on the other hand, I configured it to be an input pin, pull up, and then it triggers the advertising based on a low level. We have disable for wake up and disabled for latch. So once we have that configuration done, as you can see here, on the board, I actually have two wires from the breakout pins. One is a male header with a male, and then the other one is a female wire. So in here I have the male connected to GPIO 3, which is the output, and then a female on GPIO 4. You could use a jumper instead. I thought this was an easier way to kind of trigger and remove the connection between the two. So basically the test we're going to be doing is connecting GPIO 3 to GPIO 4, and GPIO 4 will be triggered based on low level. So when you connect the output from GPIO 3 to GPIO 4, that will trigger that, and then the advertising should start. So on here I have the mobile app running NRF Connect on Android, and let's go ahead and set up the advertising set first. So I'm going to be using the custom type. Let's call this GPIO _3_4, and I'm going to be including, let's go ahead and include the GPIO status. Okay, let's hit OK. Now let's go into the advertising parameters. Let's do this at 500 milliseconds. I have a specific MAC address here set, a Bluetooth address, so I can filter using that in the NRF Connect mobile app. And finally, in the advertising mode, I'm going to be using the triggered advertising. Now for this one, so we set up the trigger on GPIO 4 to be in low level. That's what we're looking for. So we go back to advertising. In the advertising mode, we go and select MGPIO 4. Once you hit OK here, now we're ready to run in RAM. Again, always it's a good practice to reset the board by hitting the K1 button, and then you can run in RAM. So as you can see here, we're running. Okay, and on I need to adjust the MAC address here. So it was starting from the most significant byte, it was 01, 02, all the way to 06. 01, 02, 06. Okay, all right, so if I scan now, I can see there are no devices. So what we want to do here is just basically connect these two wires, and we should start seeing advertising data. So I just momentarily connected it, and we can see here that the advertising data was sent, and we have the GPIO included in the manufacturer specific data, which reflects F5. If I convert that, F5 is this in binary. It starts from GPIO 0, 1 to 3 and 4. So 3 is the output, and that is set to 0 all the time. And then GPIO 4 right now is 1 because it's disconnected. If I go back and connect it, we see it's E5 instead of F5. So let me keep them connected and let's convert E5 and look at the binary, and we can see here that GPIO for the bit is set to 0 now instead of 1. If I disconnect and we look at the advertising, we'll see that the status changes to F5. So that's it in terms of going over how to configure the different GPIOs for the IN100 using the NanoBeacon Config tool. Thank you for watching, and I'll see you in the next one.